Hi, AP Calculus students. Welcome to the 3.4 worked out video for 29 and 57. Sorry, I had to break them up into two pieces. Wow, lots of things going on there. So on number 29, we had actually worked out everything for this function where the critical points were, where the function was concave up or concave down. Right. And what we had gotten down to was that there must be an inflection point at a negative square root of 3/3 because the second derivative was 0 there and the concavity was changing. Same thing at the inflection point where x is a square root of 3/3 because the concavity was changing. Right. And so, sorry, just move you over a little bit. So we just needed the y value of that part, and that's what Nina was asking for. So we are just going to put a negative square root of 3/3 into the x squared here and work that out. Okay, so when we square a negative square root of 3/3, we have a positive 3/9, which is 1/3. And we have 1/3 plus 1. Right? And that 1 is actually 3/3. So now what we have is a 4/3 in the denominator, right? That's what's going on. So we have 4 divided by 4/3, right? Or we should multiply by the reciprocal instead, multiply by 3/4. And the 4's cancel, and we get a 3 for the y value. Okay. Notice when we put in a positive square root of 3/3, we actually have the same math. And so we get a 3 here. Hope that helps, Nina. Okay, number 57, draw the function f such that the derivative is increasing. Okay, when they say that the derivative is increasing, they are telling you how the first derivative is changing, which means that they are referring to the second derivative. When a first derivative is increasing, if you drew little slopes, the slope of a first derivative is the second derivative, and they are positive. So they are saying when the derivative is increasing, that means that the second derivative is positive and our graphs are all concave up. Okay. So when they say, let's draw a graph of A and B, if the derivative of f is greater than 0, that means for the function f, when its derivative is less than 0, that means that the function is decreasing. When the first derivative is greater than 0, that means the function is increasing. Right? Because imagine a function that's increasing, all the slopes of the tangent lines would be positive, the derivative would be positive. So what they've asked me to do on A is draw a graph of a function that is decreasing and concave up. Decreasing and concave up. They've asked me on B to draw a picture of a function that is increasing and concave up. Increasing and concave up. So decreasing, concave up, as I go left to right, decreasing, and it's concave up. I'm hoping I said that right the first time. And then B, increasing and concave up. And there are 29 and 57 for 3.4.